Here, emission system. This is basically the first book test of emission systems, the fuel and emission control textbook. And I'm looking at what you guys need to be able to do when you walk up to a vehicle out there and somebody opens the hood. You need to be able to. Somebody says, "What's that component?" You need to be able to tell them. And there's typically a great deal of confidence that's lost in a person that doesn't even know what they're looking at when they open the hood. You know, like if somebody's standing there and they say, "What's that?" You know, like if the customer's standing there and you say, "I don't know what that is," but if you know what it is, you know, it gives an idea that you maybe know what you're doing when it comes time to fix it.
You better start teaching us.
Yeah, I know. You need, and we'll go over some of that stuff. A freeze frame is generated on the OBD2 vehicle when
I'm gonna guess B.
When a type A or B diagnostic trouble code is set. And that would be, you're basically, and who has seen a freeze frame list?
I think I've seen one before.
You actually seen them. You probably sometimes didn't know what you're looking at. On that scan tool that we've been using lately, it's actually got a place where every code that is every code that has been set, if it's an A or a B, is going to have a bunch of freeze frame data. What is freeze frame data? Anybody, can you describe? It's a snapshot that the engine controller takes.
Just to describe it and then describe it to us.
I know. I was afraid you were going to give me a crazy answer. What is your answer? How would you say that?
I was going to say that whenever I guess that specific code fires, then it takes a snapshot of whatever happened at the time that set it off.
It's a certain number of PIDs. And used to, it was only like 10 PIDs. It was basically, what do you think you would need to know about if you were going to choose which PIDs were captured? I would want to know what the engine temperature was, how fast they were going, what the throttle angle was, what the fuel trim numbers were, you know, that kind of thing. So if you look in there, you're basically the Chrysler scan tool, the old DRB3, it used to have what they would call a similar conditions window. And so if you actually got a scan tool code, and you know, the problem with a code, what's one of the problems with a code? If you pull a diagnostic trouble code, and let's say that it says it was running lean, like PO170 whatever, you know, PO174 whatever, running really rich. But you look at it right now and it's not running rich. What are you going to do about that? Because you'd be surprised how many times that happens. At some time in the past it was running too rich or too lean, but right now the fuel trims look good and it's okay.
I guess maybe see what the temperature was that was outside when it was running.
Yeah,
What
you need to.
the engine was.
Yeah, I would be looking at the freeze frame data. When was that set? It's going to tell you what was going on when it was set. All right. Let me ask you this: what if it said it was reading lean, and what if you looked at it and it was at wide open throttle and they were going 68 miles an hour when the code was set? What would that make you think? Wide open throttle, 68 miles an hour. It sets a lean code. You're going to slap yourself when I tell you. Think. Fuel filter. That's not complicated, is it? You're into it really strong and heavy. How many of you guys have ever heard of somebody changing a fuel filter because the car wouldn't start? That's dumb, with all due respect to whoever did it. You know what I mean? Because the fuel filter is typically not going to keep it from starting. If it's going that far, it's got a bunch of water in there, and you got bigger problems than a fuel filter. But the fuel filter typically only shows up whenever you're really, like you're trying to pass a car out there on the freeway, and you're really into it. It feels like it's running fairly good, and then all of a sudden you start losing power and whatnot. Another thing that can feel that way is a mass airflow sensor that fails in range. Now, you remember when I was talking about the range of the throttle position sensor? You know what an in-range failure is? That means that it begins to tell a lie, but it's in the normal range when it does it. You've already gone past half throttle on toward full throttle, but it stopped reading at half throttle, and that's where your engine controller is going to limit you to 55 miles an hour or whatever. I was driving this Pontiac Aztec that came in here, and the guy says, this thing just won't hardly go over 55 miles an hour. And so when we went out there, I got on it, had a bunch of people with me, scan tool looking at it, wouldn't go but 55. I looked, the mass airflow would never read over about 2.5 volts, you know, or about half amount of airflow. And I unplugged the mass airflow sensor, and then it defaulted and started using the map, and it would run like a race car. What did I know then? It felt like fuel, but basically it was an electronic fuel delivery issue. Got that? Okay, this is one of the things I'm trying to sort of beat into you as I go here. An ignition misfire or fuel mixture problem is an example of what kind of diagnostic trouble code?
Is it B or A?
That's gonna be an A. If it's basically got A is really a serious one, right?
Something you were saying yesterday, A was an emissions. type.
Well, it is. I mean, if it can damage the catalyst, basically, is what you're looking at. If it's a serious enough code, the comprehensive, if it's really making a big impact on emissions, and it also is a catalyst damaging misfire. Let me tell you something else they'll do. Listen to this, because it may smack you around. I got a Ford Windstar one time that I was working on that was about a 06 model, and on most of them the EGR feeds right in behind the throttle plate. You know, you'll have the throttle plate right here going through there, and then here's your manifold going down the cylinders. And the EGR will typically be right there, you know, with its vacuum line going to it. And it's going to open up and it's going to let exhaust go in right behind the throttle plate. Why? So every cylinder will get the same amount of EGR. Okay, on some of these, on this Windstar, it didn't have it set up that way. It was feeding the EGR through at the base of this thing, where each cylinder had a little 1/4 inch or so hole that was feeding EGR to each cylinder. All right, what happened on that one was every single hole stopped up except number 4. So when I started getting EGR, I was getting all of my exhaust gas recirculation into cylinder number 4, and I was misfiring on cylinder number 4. So I'd crack the throttle, EGR would come online, I would start getting, and it was a dead misfire. I was getting a P0304 code, right? Are we together now? I'm getting a P0304 because I've cracked the throttle, EGR starts to flow because the engine's warm and I'm off throttle, and it starts dumping EGR in there and it starts misfiring on cylinder number 4. Okay, now what did I do? What do you do when you got a misfire? First thing I'm going to do, am I losing spark to that cylinder? Am I losing, what else am I losing? I got maybe spray some soapy water on the spark plug wire and see if it's, you know, punching out the side. I've done that before. So I had no issue with spark, but what I did have an issue with, when I listened with my stethoscope, the injector would stop clicking. Got me? We're dumping EGR, it's misfiring on that cylinder. What's the PCM doing? It's picking up a misfire on cylinder number 4. Now what's the PCM thinking? I don't want fuel going in there if this cylinder's not firing, so I'm going to cut off the fuel. Now you can understand if you're a logical thinker like me, and this is the first time I'd seen that, it was like in 1996 or 7. I said, okay, I've got all of these holes except number 4 are stopped up. All my EGR is going into number 4. EGR is actually going to be, it's inert gas, is going to keep it from burning as hot. But if all of it's going in one hole, that hole's going to misfire, and the rest of them are going to pop just fine. I thought we had a problem with the engine controller. Why did I think that? Because I lost the signal to fire the injector when the skip started taking place. My injector went to sleep. Aha! Well, my injector, the ohms read okay, like 16 ohms. And then I said, okay, well, I got a good connection all the way to my engine controller on that wire. I'm not losing that, not rubbing against a bracket or anything. Don't have a bad connection in any inline connector or anything like that or at the engine controller. So I started thinking maybe the driver in the engine controller had gone to sleep for whatever reason. And that's when I figured out that that wasn't the fact. The way I figured that out, and I don't even remember why I did this, but I said, what's going on when I crack the throttle that's not going on when I know? Well, EGR is flowing. So I pull the vacuum line off the EGR valve and this skip went away. And that totally blew my earlier diagnosis completely out of the water. And then when I pull the intake off, I find all of these hoses clogged up except one. And it's fairly easy to clean them out. You know what else will do that? Some of these little 4-cylinder Nissans will do that. And you know how it'll manifest itself? You'll be driving down the road and you'll feel a surge. And when you unplug the EGR valve, the surge goes away. They got little holes just like that. All of them will clog up but one. See what I mean? You won't get this anywhere else. You better pay attention. You got me? You remember that, ain't you, Curtis? All right. The comprehensive component monitor checks computer control devices for, hold on, let me see what Deborah wants. Hello, Deborah. Yeah, I was giving a lecture. It won't be long. Okay. All right. Okay. Comprehensive component monitor checks computer control devices for what? Everything. What's comprehensive component monitor mean? And how would you check something for functionality anyway?
See if you're getting a signal.
Well, yes, sort of, but how do you know? Let's say that the throttle, you were looking a while ago at that little Bluetooth scan tool thing. You're seeing me move the throttle, but you're not seeing the throttle respond. That you're basically comparing what your eye sees to what your tail doing, right? Well, that's the same thing the engine controller does. It's looking at functionality check, rationality checks, I like to call them, because what happens is it's going to increase the idle air control, right? Whenever it increases the idle air control, you should be getting more airflow. I'm increasing idle air control. What if I increase idle air control, or I see throttle position increase, but my mass airflow does not increase? Mass airflow and throttle position should run together. All right, if one of them's staying flat and the other one's moving, I've actually determined that there's something going wrong there. Hear me? I mean, you can figure that out yourself looking at a scan tool too. Okay, opens. What's the difference between a short and an open? A short's whenever you got a short's when you got two wires touching or you got a wire touching ground. An open's when the wire's cut. Got it? Usually whenever somebody sees something, when you wiggle something and it doesn't work every time, they say it's got a short in it, but it's more likely an open, you know. So we need to keep that in mind. But rationality, functionality, everything it can do to watch, you know, voltage changes and all that. If you're driving down the road and your oxygen sensors are flat, but everything else seems to be normal, or if you got one oxygen sensor reading normally and the other one's reading flat, you know, that's a functionality thing. You're actually going to be looking, computer control devices, be fuel injectors, be your, all the solenoids that operate it. They're not emission related, but transmission control solenoids that operate that way too. The vapor management, which would be your, you know, your evap system, those things, it's going to be checking those. All right, now let me ask you this. What if it sees that there's no electrical problem, but it also notices that what it's commanding is not being done? That's a functionality check too, isn't it? I don't see an electrical problem. I actually see 12 volts coming through my little solenoid, and when I energize it, the 12 volts goes away. So I know that the circuit's complete, but the solenoid is not moving because the spring is broke or it's stuck or whatever, you know. That's that. OBD2 has been on all passenger vehicles in the United States since when?
91.
No, OBD2's, no, it's 96, but I was seeing some 97 model 1-ton pickups that didn't have OBD2 on it, so I think the drop dead date was 98, but 96, yeah, you can pretty much say that 99.9% of all vehicles had it in 1996. I know Mitsubishi had a terrible time getting it to work, if I remember right. I remember hearing that in school. Which of these is a continuous monitor? Oxygen sensor, EGR, catalyst, or fuel system? The only one is fuel system. And the reason for that is the oxygen sensors are not always going to be working. There's going to be times when they're too cool to work.
Oh yeah, that's right, because they said they only work above like 600 degrees.
There you go. And they'll get to 600 degrees pretty quick if the heater's working. EGR is not always working either, is it? The catalyst monitor, the only time it can be monitored is when you've been above a certain speed for a certain amount of time, and you're holding that speed. There's actually whenever you're driving around to clear all of your monitors, you know, you got all different kinds of monitors that have to clear, and they actually make a thing similar to that little Bluetooth thing over there that's only there to tell you when all the monitors have cleared. And you just drive normally. You drive through town, you drive on the road, you drive around, and when that thing goes beep, you know what the hardest one to clear is? The doggone evap monitor. When you're trying to clear an evap monitor, you may drive that thing for 30 minutes or 45 trying to get it clear, because it's a peculiar thing to do. Most of your scan tools now will actually put the evap through some paces so you can make sure it's working all right. Okay, PO302 is what?
I'm going to guess transmission or transaxle related.
No, the transaxle related is going to be a 700 series code.
Is it IL?
PO302, you guys have you've seen misfire codes before, haven't you?
Yeah.
But this is not one of the question answers, is it? I mean, it's not one of the answers, is it?
Well, what I was going to say is I know that the cylinder misfires are like 034 over.
No, it's actually PO30. This is a cylinder 2 misfire. But the four answers are idle speed related, transmission transaxle related, vehicle manufacturer specific, or generic. I would say
Generic?
generic, because it's, you can look at that thing up there, see, it's P1 something if it's manufacturer specific, it's PO something if it's generic, right? Something I failed to tell you yesterday when I was talking about the two rooms in the engine controller is that we actually had an escort out here that had an injector that wasn't seated, the connector wasn't seated good, and it had a PO301 code in it. And I cleared it from the enhanced room, but the check engine light didn't go off until I went into the generic room and cleared it in there too. That almost never happens, but that smacked me around some. I never could have, I felt like if you cleared the codes, you cleared them all. But if you're in the enhanced room, it may leave some codes in the other room, you got me? Or you may not pick up all of your codes in your generic room that are there either. Global generic OBD2 contains some data in what format?
Hexadecimal.
Yes, hexadecimal is good. Good answer. By looking at the way diagnostic trouble codes are formatted, what diagnostic trouble code could indicate the gas cap is loose? Look at the way they're formatted. Yeah, B is going to be a PO442. Now you think about that, the 400 series codes are, EGR, gas cap related. You notice that. The 500 series codes are speed related. Maybe engine speed, maybe vehicle speed. And then understand how that works. And then your 700 series codes are transmission related. 200 series codes are typically ignition related. And 300 series codes have got to do with misfires, technically, which can be ignition. But I mean ignition coil. Like if you got a coil-on plug and one of your coil-on plugs is shorted or the wire's cut going to it, they'll throw you a 200 series code for that. See, which is if you learn how to parse those codes in your mind, a lot of times you can get a pretty good idea of what's going on as soon as you see the code without even having to look up a definition of it. The computer will automatically clear a DTC if there's no additional detected faults after how long? 40 consecutive warm-up cycles is the right answer to that one. Unless you read that particular paragraph, you probably wouldn't have caught that. A pending code is set when a fault is detected on what? The first fault of a true two-trip failure. In some cases, if you get two good trips, the light will go off. It'll reset itself. Sometimes there's product variability in the field. There's a fluke. Technician A says when the mill is on, the technician should retrieve the DTCs and follow the manufacturer's recommended procedure to find the root cause of the problem. Technician B said all OBD2 monitors must have enabled criteria achieved before a test is performed. Who's right about that? Actually, C is right about that. What do? If I go out here and I've got somebody comes in, my check engine light's on, and I plug in my scan tool, I get a string of codes out of it. I mean, like I get 7 or 8 codes out of it. What are we going to do first? You guys are going to see this. Clear the doggone thing. Record them. Make sure you know what they are. Clear the codes. Drive it. See which one comes back first. Because that's the one you need to start with, right? If you see a string of 7 or 8 or 9 codes, they'll say, oh my gosh, what are we going to do? Basically, I'm clearing them and I'm driving it. And I'm going to see which ones come back. Make sense? You haven't had any more no start problems, have you? All right then. Okay, let me see here. A mill is turned off under any of the following conditions except, this sounds like an ASE question. Vehicle is driven on 3 consecutive trips with a warm-up cycle without detecting a fault. Codes are cleared with a scan tool. PCM diagnostic link is grounded. Power to the PCM is disconnected. The exception is C on that one, y'all. Technician A says OBD2 includes generic as well as manufacturer-specific DTCs and data displays. Technician B says OBD2 have common diagnostic trouble codes.
B. C.
That's going to be C, believe it or not. OBD2, one of the things about the J1930 regulation, one parts of it, was that they had and I hope I remember that J number right, but all of the trouble codes used to be different. When everybody had OBD1, you might pull a trouble code that would have a totally different number or nomenclature for a Honda than it would a Toyota or or Ford or Chevrolet or Chrysler. They wanted them all to be universal, where when you plugged it in, you were looking at a code that pretty much meant the same thing on every car. That was what that's a federal thing, and it works pretty good, really. A U-type DTC indicates a problem with what?
Body sorcerers.
What? Who said that? Communication relation. That's a network code. A U code's a network code, right? I mean, I was looking at them entering, and I was thinking, where's my network related? But it's communication related system. What we're talking about. An element of the OBD2 diagnostic management system, which stores engine data during a diagnostic set, is called.
D.
It's going to be D, the freeze frame. Onboard diagnostic vehicles levels 1 and 2 are being discussed. So these two guys, Technician A and Technician B, have a lot of conversations. I don't know if you noticed that or not. They talk a lot together. And in this particular case, they're talking about OBD1 versus OBD2. Technician A says only OBD2 systems require misfire detection. Technician B says OBD1 was capable of detecting exhaust emission control system failures. Who was correct about that? A is the only one that's correct. The OBD1 system had no earthly idea if your catalytic converter were working right or not. It didn't have the oxygen sensor behind the light off cat like the other ones do. Here's another thing that gets you in trouble if you're not careful. Watch this. Show you a trick here. One day, well, you'll see a 4-cylinder engine a lot of the time. And it'll have a catalytic converter right here. And then the exhaust will go under the engine, it'll go back here. And doggone it, there won't be another catalytic converter back here. Got that? All right, so I got a PO 420 code. And I said, I need a catalytic converter for this thing, PO 420 code. I didn't write that very legibly. PO 420. I didn't write. And that telling me that this is not storing. You remember yesterday the Impala was a PO 420 and needed a catalyst,
Yeah.
right? That? Because they were switching at the same time. Okay, the yo-yos in the parts room didn't ask me which catalytic converter. You know, I even mentioned to them I had a PO 420 code and I needed that. Well, they didn't know anything about that. They ordered this one. And so it came in, and they gave it to a different mechanic because I was tied up on something else. He popped that converter on it, cleared the code, sent it out. They were back in 20 minutes and said, we got the same code again. Of course, it was under warranty anyway, so it wasn't like I spent a bunch of money with it. And I looked, and the oxygen sensors were here and here, which means this is the one we needed, not that one. And I saw that again after I came here. This girl that worked here came and she says, I got a code, PO 420. I said, it's covered under warranty. Take it to the dealership. She takes it to the dealership. It comes back. And she said, it came on again. And I looked under the car, and sure enough, they changed that one, and this one here was still old. So I called them back up. I called the dealership. I said, you know what happened with this thing, you know? And then they, oh, well, you know, somebody dropped the ball on that, you know. It's an easy mistake to make if you're not thinking what you're doing. The one that is sniffing this light off cat's the one that you're going to get a PO 420 on. It doesn't know what's going on with this one, but it doesn't really need to. Okay, just remember that. This is the kind of stuff I've learned the hard way. Let's see. In an OBD2 system, when all enabling criteria are given for a diagnostic is met, when all enabling criteria for a given diagnostic is met, it's considered which of these? A trip. That's right. Technician A says warm-up cycles are used to erase diagnostic trouble codes and freeze frame data. Technician B says OBD2 requires the use of diagnostic system to monitor all emission-related components and systems. Which technician is correct?
Right.
That's going to be C. Which organization developed guidelines for OBD2?
EPA.
And
No.
the California Air Resources Board. You know what, there are a group of states that have emission laws that are tighter than the rest of the states, and those states are called green states. So if you see something talking about green states, you'll have to figure out, you know, which states are green states. As a matter of fact, if you pulled out your smartphone and said, speaking in an automotive, whatever, which states are green states, and they'll tell you which states are basically green states.
Clearly not Arizona.
Yeah, if a vehicle is put together to be sold in a green state, it's got different regulations. Just like California versus federal. If you look at your VECI decal under the hood, California versus federal is a significant issue because it's going to have different components and stuff on it if it's California. Which of these is checked during an OBD2 functionality test?
EC2.
Actually, believe it or not, it's the transmission shift solenoids. And that was kind of what I was talking about a while ago. The thing knows, it knows that whenever it turns on the solenoid A and solenoid C, you're supposed to shift into second gear or whatever. If it's turned on solenoid A and solenoid C and you're still in first gear, it knows that it's commanding second gear, but it's not getting it. And it's basically, it'll give you a check, functionality check on that. And that's not even emission related, but the PCM it's got its fingers in that passive. All right, anybody got any questions?